Hi students, now continuation of the topic virtualization for data center automation. The further concept you have to learn now, that is nothing but the concept is virtual storage management. What does it mean? We have seen in system virtualization, virtual storage includes the storage managed by virtual machine monitors and guest operating systems. Generally, the data stored in this environment, it can be classified into two categories. First one is virtual machine images and the second one is application data. What does the word the storage virtual storage management here we what does exactly it means? In the sense, the word storage virtualization was widely used before the renaissance of system virtualization. The term has a different meaning in a system virtualization environment. Previously, we want to storage virtualization was largely used to describe the aggregation and the partitioning of disks, repartitioning of disks at very coarse time scales. For by physical missions, we want to say it includes the storage managed by virtual machine monitors and the guest operating system. Generally, we want to store some data. We want to store the data in this environment. It should be generally the data stored in this environment. It should be classified into two categories. Okay, how many categories? Two categories. The first one is virtual machine images and the second one is application data. Coming to the virtual machine images are special to the virtual environment. What ma? It is a special one to the virtual environment. And coming while we can say the application data, it includes all other data which is same as data in traditional operating system environment. Okay, while application data includes all other data which is same as data in traditional operating system environments. So the most important aspects of the system virtualization are encapsulation and isolation. Okay, in this concept, with the most aspects of system virtualizations are two. First one is encapsulation and the second one is isolation. We want to see the traditional operating systems and the applications running on them. It can be encapsulated in virtual machines. Okay, only we can say the one operating system runs in a virtualization while the many other applications run in the operating system. The system virtualization allows what it allows the system virtualization allows the multiple virtual machines to run on a physical machine and the virtual machines are completely isolated. Okay, this is the concept of virtual storage management. And then what we want to achieve, where we can achieve to achieve encapsulation and isolation, the both system software and the hardware platform such as what that CPU and chipsets, what's ma CPUs and chipsets, or it is rapidly it grown updated. However, we want to tell about this storage. It is lagging. It is storage is lagging. So the storage systems, it becomes the main bottleneck of virtual machine deployment. So in this concept of virtualization environment, a virtualization layer is inserted. What ma? A virtualization layer is inserted between hardware and traditional operating systems, or a traditional operating system, it is a modified to support the virtualization. In virtual environment, a virtualization layer is inserted between the hardware and traditional operating systems. It is modified to support the virtualization concept for storing the management. This procedure complicates to store this procedure complicates the storage operations. What we want to store the management of the guest operating system, it performs as though it is operating in a real hard disk. Okay, it is operating in a real hard disk, while the guest operating system cannot access the hard disk directly. Storage management of the guest operating system performs it is a operating system in a real hard disk, while the concept of guest operating system, it cannot access the hard disk directly. So many guest operating system contest the hard disk when many virtual machines are running on a single physical machine. So therefore, the storage management of the underlying virtual machine monitor is much more complex than that of guest operating systems, nothing but traditional operating systems. Okay, and we want to see some operations, how it should be work. Okay, the operations such as we see for techniques for establishing the trusted zones for virtual cluster insulation and virtual machine isolation. For we have to discuss in this cloud operating system for virtualized data centers. Okay, listen, cloud is the cloud. We want to store some distributed network, widely distributed network. Okay, cloud is nothing but widely distributed network. It should form of a computation, and we want to store some data with the help of cloud data center. Now we have to discuss now the topic cloud operating system for virtualized data centers. Now we discuss the data center concept here. Here we have seen here the look at here virtual infrastructure managers and operating systems for virtualizing data centers. Now we discuss the concept here cloud operating system for virtualized data centers. First of all, we need to learn data centers. Data center must be virtualized to serve as cloud providers. Okay, to serve as cloud providers. Here the table shows you, it summarizes the 4 virtual infrastructure managers. What my here VI in the sense virtual infrastructure managers and operating systems for virtualizing data centers. Okay, we want to summarize here the 4 virtual infrastructure managers and operating systems. These virtual infrastructure managers and operating systems are specifically virtualized for the data centers, okay, which often own a large number of servers in clusters. Like we can see the large number of servers in clusters. First one is Nimbus. Okay, Nimbus. Next one is Eucalyptus, and third one is Open Nebula. Are all open source softwares. These are all open source software available to the general public. And coming to we have seen the only vSphere 4 is a proprietary operating system for cloud resource virtualization and management. Okay, vSphere 4 is a proprietary operating system for cloud resource virtualization and management over the data centers. These virtual infrastructure managers are used to create virtual missions. What we want to create here? Virtual missions, and aggregate them into virtual clusters as elastic resources. And coming to the Nimbus and Eucalyptus, it supports essentially the virtual networks. And we want to discuss the Open Nebula. It has a additional features to provision the dynamic resources and make advances reservations. So all three public virtual infrastructure managers apply the Zen architecture and KVM for virtualization vSphere. Okay, in that one we have to use the four uses the hypervisor. First one is ESX, okay, and ESXi from virtual machine software. Only vSphere 4 supports the virtual storage in addition to virtual networking and data protection. We will study the Eucalyptus and vSphere 4 in the next two examples. Okay, what we have to read here? Okay, here we can see the data centers must be virtualized to serve as cloud providers. Here the table summarizes you the virtual infrastructures VI, it manages and operating systems. These virtual infrastructure managers and operating systems are specifically tailored for virtualizing data centers which own a large number of servers in clusters. Like we can see Nimbus, Eucalyptus and Open Nebula are all open source softwares available to the general public. Only vSphere 4 is a proprietary operating system for cloud resource and the virtualization. Okay, this is the concept of cloud operating system for virtualized data centers. Now we can explain now Eucalyptus for virtual networking of private cloud. What does it mean? Now we can see Eucalyptus for virtual networking of private cloud. Here we can see the Eucalyptus is an open source software system. It is mainly intended for supporting infrastructure as which infrastructure as a service cloud. Okay, here so the system primarily supports the virtual networking and the management of virtual missions, and the virtual storage is not supported here. It's the purpose to build the private clouds that can interact with the end users through Ethernet or the internet. So the system also supports the interaction with other private clouds or public clouds through over the internet. So the system is short on security and other desired features for general purpose grid or cloud applications. Okay, this is the concept of Eucalyptus for virtual networking of private cloud. If you have to take what the designers of Eucalyptus implemented, in the sense each high level system, the component should be standalone web service. Here the each web services exposes a well defined language in like agnostic application programming interface in the form of you can say the document containing the both operations that the service can perform the input and output data structures. Okay, this is the concept of Eucalyptus. Okay, we can see for virtual networking of private cloud. And coming to the concept of trust management in virtualized data centers. Okay, in coming to this trust management, what we want to trust in that management to the with the help of the cloud, we want to the cloud is a open source. Cloud is nothing but it's a widely distributed network. It should be cloud lo manam service anedi virtual ga jarugutundi. Okay, how the trust management in virtualized data centers. Okay, now we discuss here. A virtual mission monitor changes the computer architecture. What here the virtual mission changes the computer architecture. It should be modified. It provides a layer of software. It provides what it supports a layer of software between the operating system and the system hardware. It should be the operating system and system hardware. It provides a layer in between that software, okay, to create one or more virtual missions on a single physical platform. We want to create a single physical platform. We want to support here one or more virtual missions on a single physical platform we want to create. It provides some layer in between software like the operating systems and the system hardware. Okay, virtual mission monitor, it can provide the secure isolation, and a virtual mission accesses hardware resources through the control of virtual mission monitor. So the virtual mission monitor is the base of the security of a virtual system. Normally one virtual mission is taken as a management of virtual mission to have some privileges such as to creating, to suspending, to resuming, or to deleting a virtual mission. In the sense, what we have to say in the sense, a virtual mission entirely encapsulates the state of the guest operating system running inside it. Encapsulated mission state, it can be copied and shared over the network and removed like a normal file. Okay, which proposes a challenge to virtual mission security. In generally, we want to say a virtual mission monitor, it can provide the secure isolation, and a virtual mission accesses the hardware resources through the control of the virtual mission monitor. So the virtual mission monitor is the base of the security of a virtual system. That's why we want to say normally one virtual mission is taken as a management virtual mission to have some privileges such as to creating, suspending, resuming, or we want to deleting a virtual mission. Okay, once a hacker successfully enters into the virtual mission monitor or management virtual mission, the whole system is in danger. In the sense, a problem arises in protocols. Okay, a problem arises in protocols that rely on the freshness of their random number source for we want to generating the session keys. Okay, for we want to generating the session keys, considering a virtual mission as a virtual mission monitor, we want to say some random number source for generating the session keys here. Okay, we want to consider a virtual mission software, okay, virtual mission monitor, okay, to build to rolling back to a point after a random number it has been chosen. Okay, considering a virtual mission rolling back to a point after a random number has been chosen, but before it has been used, it resumes the execution. Okay, it resumes the execution. Okay, the random number which must be fresh for security purposes, it may be reused. Okay, and coming to the finally we discussed virtual mission based intrusion and detection. What we want to intrusion and detection. Virtual mission based intrusion detection. What does it means? Now we have seen. Intrusion detection is used to recognize the unauthorized access. What we want to recognize here, the unauthorized persons, which persons are accessed, that persons will be, we can recognize the unauthorized access. Okay, intrusions or unauthorized access to a certain computer from local or network users. Okay, and intrusion detection is used to recognize the unauthorized access. An intrusion detection system, it is built on operating system. Okay, it is built on operating systems, and it is based on the characteristics of intrusion actions. Okay, here, so a typical intrusion detection system, it can be classified as a host based intrusion detection system or a network based intrusion detection system. Okay, it depending on the data source. Okay, depending on the data source. First of all, we want to discuss first one is nothing but host based intrusion detection system. Okay, intrusion detection system, what does it means it can be implemented on the monitored system. When the monitored system is attacked by hackers, the host based intrusion detection system also faces the risk of being attacked. What ma? Risk of being attacked. A network based intrusion detection system is based on the flow of network traffic. Okay, it's based on the flow of network traffic which can't detect the fake actions, which can't detect the fake actions. Coming to the network based intrusion detection system is based on the flow of network traffic which can't detect fake actions. Okay, coming to this concept, virtual mission based intrusion detection, here we want to discuss the virtualization based intrusion detection. It can isolate the guest virtual missions. It can isolate the guest virtual missions on the same hardware platform. Okay, in virtualization based intrusion detection, it can isolate the guest virtual missions on the same hardware platform. Even we can say some virtual missions can be invaded successfully. Okay, they never influence of other virtual missions, in the sense which is similar to the way in which a network based intrusion detection operates. Furthermore, we discuss a virtual mission monitors and audits the access requests for hardware and system software. Okay, we want to monitor and audit access request for hardware and system software. This can avoid the fake actions. Okay, this can avoid the fake actions, and it possesses the merit of host based intrusion detection system. There are we can say in this concept there are two different methods for implementing a virtual based intrusion detection system. Either the intrusion detection system is an independent process in which each virtual mission or a high privileged virtual mission on the virtual mission monitor, we can say the intrusion detection system, it is integrated into the virtual mission monitor, and it has the same privilege to access the hardware as well as the virtual mission monitor. Okay, this is the concept of virtual mission based intrusion detection. Okay, later we discuss the fourth unit, that is nothing but programming model. Okay, later we discuss in further videos. Thank you, ma.